right, let's go through some examples of how we'll use the explicit rule, which is that any term we're looking for will always equal the first term plus d times the number of terms minus 1. Okay, so now here we're looking for the 41st term in the arithmetic sequence. So now let's take a look and say, okay, what are we talking about? What is everything that we need here? So the first thing we need is we need what term we're looking at. And we're looking at the 41st term, so it's our n is 41. Our first term here of this sequence, you can see right here, is the 11. So our a sub 1 is the 11. Next thing we have to do is we have to calculate our d, and then we're going to have everything we need to find the answer. Well, to calculate the d, you always take the second term minus the first term, and you're going to get your d. So in this case, 4 minus 11 is negative 7. Okay, so our d here we know now is negative 7. So now we can kind of calculate our equation. So we can kind of follow this equation right here, and we can say the a sub 41, the value that we're looking at, is really the first value, 11, plus our d, negative 7. That means each time it's like minus 7, minus 7, minus 7 here. And then we really have here 41 minus 1. That's our equation. So really on our calculator we're going to take 11 plus negative 7 times 40. All right, let's see what we get when we do that. 11 times negative 7 times 40. We get for an answer, our answer is negative 3,080. So our answer here is negative 3,080. That is the 41st term. Now it's not all those terms added up. Remember that sometimes we have them where they're all added up. That's not what we're talking about here. It's actually the 41st term. So now we're going to find the 100th term in an arithmetic sequence. So now for this problem, our n equals 100. We can look at the values they gave us and we can find that the first term equals negative 9, and we have to calculate our d. So I'm going to come over here, I'm going to calculate my d. d would equal negative 7 minus a negative 9. Minus a minus would change those two to plus, and so it would really be negative 7 plus 9, so our d is 2. Okay, so now I know my d equals 2. So now I can plug my values in. The 100th term would be the starting term, negative 9, and then our d is 2 times 100, and I have a mistake here, minus 1. My mistake is here. I have acted like this was multiplication, and I apologize. I kind of ran out of room. I kind of panicked, I think, with the room missing. So it's 100 here, and it would be our starting value plus those two multiplied together. So this would actually be 2 times 99. And just for simplification's sake, our answer there is 207. I kind of did our calculations there. Now our third problem here. Now we know the last term, or the 44th term. We know our d. We want to find our first term. We want to find our a sub 1. So our formula is that our last term that we care about, really, it's not necessarily the last term, but the 44th term, so here our n would equal 44 in this case, would equal our first term, what we're looking for, plus our d times the number of terms minus 1. Okay, so 88 here times 43, I'm grabbing a calculator, oh excuse me, I said 88, 8 times 43 here would equal 344. We have our a sub 1 and we have 299. I'm going to subtract 344 from both sides, and I get negative 45. So our first term had to be a negative 45 if every time when we added 8, added 8, added 8, on the 44th time we got 299. Sorry about that. All right, so find d for this sequence. We have our a sub 1. We have our a sub 11. That means our n must equal 11. We have to find our d. Well, our formula is that the last term, our a sub 11, equals our first term, our a sub 1, plus d. We don't know what d is, but then times n minus 1, times 11 minus 1. So our problem here is 8 plus really 10d. We can subtract 8 from both sides. 18 equals 10d. And our d had to be 1.8. So each time we were adding 1.8, adding 1.8, adding 1.8. Now let's talk about if you don't know what n is. So now what we know is we have our a, we have our first term, our last term, our a sub n, and we have our d. So it's just telling us a sub n. We don't know what's n. That's what we're trying to figure out here. So our formula, our last term, 138, would equal our first term, -2 plus d n times n minus 1. Well, let's try to figure out what this n minus 1 is. There's a couple options you could do here. One option is to do distributive property here. Okay, -2 plus 7n minus 7. All right, we could do that. Then we could add together the -7 and or -2 and -7, and really have -9 plus 7n's equal this 138. Add 9 to both sides. 147 equals 7n. And then n, if I divide both sides by 7, must equal 21. I think that's as quick. We could have first added 2 to both sides. We got 140, and then divided both sides by 7, and that's what 7 minus n is. And we could added 1 to get to the 21. Either way, you would got the right answer. There's just a couple different routes to get to that answer. The last topic we have is arithmetic means. And this is the terms between any two non-consecutive terms of two non-consecutive terms of an arithmetic sequence. All right, so in other words, consecutive would be like if you had them in order. So 2, 4, 6 is my easiest one. Consecutive is here. So basically it's kind of like I took a and this is not necessarily what we have, actually it is what we have, and I said what were those values in there? All right, what did I have in here for these values? All right, and so yes, we could have just figured it out, and a lot of times it's really easy to just figure it out and go, logic tells me that. But what you also have here is you also have your a sub 1, you also have your a sub n, all right, here, and you can figure out how many terms we're talking about. We had 1, 2, 3, 4, 5 terms. So you can kind of figure it out that way and say, and you're really trying to ask yourself the question, what's D? What was D? And if I know D, then I can see how much does it change for by each time. Like in this case, it was +2. +2. Oh, sorry. +2. I got messy there all of a sudden. Okay? So let's look at the next example here. We have 6 arithmetic means between -12 and 23. So that means there's 1, 2, 3, 4, 5, 6 spots, and then the 23. So our a sub 6, 7, 8, a sub 8 is this 23. Our a sub 1 is 12. We don't know what a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and a sub 7 is. That's what we have to figure out. To do that, we first have to figure out D. So we do go back to our original formula of the last term equals our first term plus our D times n minus 1. Okay, so the last term here was 23. My first term was -12. I still have to figure out my D, and we know we have 8 terms. If I added 12 to both sides, I'd get 35. And then I really have here 7 times D. So therefore, my D had to be 5. Okay, if each time I was adding 5, and that's what the implication is when it's positive, this would be -7, this would be -2, this would be +3, and then 8 plus 5 is 13, 18. Please tell me I added right. Yep, to 23. So, sorry about that. My answer here is basically those numbers, but really the whole answer is you should kind of expand it and leave all of them, but we're going to leave those numbers. So here, we're going to talk about this at another time when we have a sum of a series. We're going to have another video. What I want you to do for tomorrow is I want you to look at this page 763, and I started at 17, I went all the way to 49, and I want you to do the odds. There will be another video where we're talking about the series. when we have a series where we're trying to find the sum, all right, well, or excuse me, a sequence when we have the sum and we have to find the answer of it. So